Kemal Ekenel from Istanbul Technical University. Our lab is named SIMIT Lab. Officially, it stands for Smart Interaction and Machine Intelligence Lab, but we mainly use it as Simple IT or Simplify It, because although we are computer engineers, we believe in human-human interaction. We are from Turkey, so we like to have a cup of tea and maybe simit along with it and then chat. So normally I would have liked to be in the Metu campus, but yeah, maybe this time it's a distant talk, but next time hopefully we can meet face to face. That's what I would have preferred also. Today I will give an overview of what we are doing in Istanbul at Istanbul Technical University. It will be a summary of our activities. I will also give a historic perspective about what we have done. And then I will also talk about what we are doing. So these pictures are not very up to date. Some of the faces you see here have already graduated. Some of them are still with us. I think I have seen Ali is with us. I think Erdi is with us. I think I also have seen Izzet with us in the audience. So I have been with ITU for over 10 years now. And yes, I mean, not only me, but as a group, we like to get together and chat and have a piece of cake and tea along with it. So the left is more the former times before COVID. And then we moved to online meetings for a while. But nowadays we are still, we moved back to meeting face to face. So historically, lab was dominated by bachelor students, but recently we have more grad students than undergrads, but still we also have bachelor students, many graduation thesis projects, as well as undergrad volunteers. So I'm a professor at the Department of Computer Engineering. I have been with ITU since 2011. From 2017 to 2020, I was also partially affiliated with EPFL, Signal Processing Lab 5. Before, I was in Germany for a long time. I did my PhD in Karlsruhe, and I had my own research group afterwards. I did my bachelor's and master's in electrical and electronic engineering. They're both from Boğaziçi University. You know Istanbul Technical University, so I don't need to talk about this. So what we are doing can be counted as an intersection of machine learning, deep learning, pattern recognition, computer vision. We do a lot of practical stuff, a lot of applied research also. And in terms of the application domains, these are the categories that we are addressing most of the time. We are very active in security, like our work on faces have had a good impact in the literature. We do health or education-oriented face processing or general, with Zia, thanks to him, general health data processing. Historically, we have been also very strong in multimedia and document analysis. We used to process broadcast news videos, movies, and TV series, also performed a lot of work on document categorization and understanding. Not at the moment, but for a while we have been also very active in gaming. A subgroup in the lab was building games. I think some of them are even in market. We even had 2 spin-offs. We even had Unity license at that time, not anymore. It was mainly driven by my students. We also work on assistive technologies, like helping kids with autism or visually impaired people. And recently, we are also working on some biodiversity or ecological systems-oriented work. So that has been the historical application areas. Currently, these are our main focuses. So we still work on face analysis. We do a lot of work on lip synchronization. I will show you a couple of demo videos. So for example, let's say I'm a Qatari attending from Doha, not a Turkish. So, and I cannot speak English. So that work makes me speak English to you while I'm speaking original Arabic from here. So you see me speak English or Turkish over there. We do work on anti-spoofing. During the COVID times, these remote onboarding systems have become very common. Of course, there are many attacks to these type of systems, so we have been working on developing robust anti-spoofing systems. We do actively work on low-resolution face recognition. With Turkcell, we have participated face recognition vendor test, and we have a recent TÜBİTAK project on facial expression analysis for usability studies. Besides this, RD is working on like face generation also, and how to evaluate artificial face generation performance. In terms of medical analysis work, we have recently attended the BRATS challenge in Mikai. So we did very good work on 3D brain tumor segmentation. I think we ranked 5 out of 65 groups participating to the challenge. Zia also works on real-time pedicle annotation from endoscopic images. Together with a startup company in Istanbul, we worked on getting physiological signals from the ocular images. And then we also have a collaboration with CNR Pizza on in-bed pose estimation and monitoring people in bed, especially the infants. In terms of the Industry 4.0 oriented projects, we have worked with TechFan for a very long time. We did a very good work on digitalizing their PNID documents. So this is a piping and instrumentation documents. So they had the need for digitizing them. And then we also had some recent collaboration with Tüpraş on predictive maintenance. Regarding environment, we have recently participated a cost action on insect AI. We had a European project proposal on digital twins for forests, and then we have currently a TÜBİTAK project on drone networks for search and rescue systems. So this is what we are currently working on. We are mainly funded by public bodies, so our main sponsor is TÜBİTAK and European Commission. We also have received some indirect funding from Qatar National Research Fund, British Council, and German Ministry of Education and Research. And these are some of our collaborators. I'm a graduate of Karlsruhe, so we have been working with them for a long time. Currently, we are involved in a EU Horizon Europe project, and others you might know. So we often work with our collaboration partners. We also work heavily with industry. We work with Zoom Research for a while now. We are in the same European Union project. RAM People is also one of the recent collaborators. They do retail executive monitoring, so we are monitoring the shelves and so on. I will also move this. So we are also very active in industrial research and collaborations. So a small advertisement about the coming Automatic Face and Gesture Recognition Conference that will be held in Istanbul Technical University campus during the last week of May. So again, you are more than welcome, even if you don't have a paper. I think if we have the funding, we can arrange a free entry, especially for the students. So let me start giving the overview of research activities. Again, we are very active in the face analysis research. And of course, if you want to analyze the people, you need to detect them first. This is one of the works that we have done in Germany many years ago. No, actually, I was in Istanbul already at that time. I think we did it in collaboration. So one idea here was to identify people across different ages and especially the infants. And obviously, you cannot collect images of these people at those ages. So we decided at that time to use Harry Potter movies for that purpose. And then it was a challenging problem because those movies are relatively dark and there are many scenes with full of people, so detecting them is really very tricky. So generally, you might think that face detection is a saturated technology, which is indeed the case. But for very crowded scenes, for dark scenes and so on, it's still a challenging problem. Of course, in machine learning, we say there is no data like more data. This is another collaborative work with KIT many years ago. So here the idea was to track people in the movies or TV series so that we can acquire more information from that. And then later, if we want to do, I don't know, face recognition, gender classification, and so on, then the performance of these systems also get far better with more data. So for this specific study, we use some contextual information to improve the tracking performance, because as you might already know, there is nothing that works 100% in these type of technologies. So we were trying to keep the detection rate as high as possible while trying to remove the false positives as much as possible. Then once you detect and track people, one of the things you can do is face recognition. This is now an ancient work. This is one of the first, I think, natural person identification studies. So at that time, what people were doing was standing still, looking at the camera and waiting to get recognized. And at that time, what we have done was let them behave freely. And the other nice thing about this work was that it was one of the first samples of open set classification. People tend to do either closed set person cognition or authentication. Open set identification means you need to also determine whether the people entering the room, whether they are registered people or not, and if yes, who the person is. So this was also very interesting for that time. We also built interactive systems. So because in the old times, especially, the face recognition accuracy was not as high as what we have at the moment. So we also had systems that we have the people in the loop. So for example, you are looking for an actor in a movie or TV series. You click on that person, it retrieves the instances that you see these people. But this is like a short, small set. Let's say the recall is relatively low. So what you do is that you ask the system to return more. And the system shows you the instances that it thinks belongs to that person, but not very sure about. So you provide a confirmation. So you provide this confirmative feedback and it expands the query. So again, the recall was relatively low, but we have a very high precision. And with like 5 interactions recall, we were able to increase it to 95% with this system. You can also think the same problem for the camera networks, like in public areas or airports. Let's say you feel a bit suspicion about someone, and then you click on that person, and then you can monitor when and where this person has been in the building. In this case, it's again a person search problem, but instead of confirmative feedback in the system, we were giving a discriminative feedback. So we were providing both the correct outcomes and incorrect outcomes and providing a discriminative feedback to the system. We also built some gamification applications. This is one of the games we've built for Avaya. So it is a face recognition based paintball or laser tag style game. So what you do is that instead of throwing paint or like getting recognized from the text that you are carrying, we use face recognition to identify the people. So at the beginning, you have the similar typical gaming mechanisms like you open a lobby, you invite your friends, and then they join. And before beginning the game, what you need to do is that you need to collect a couple of face images. So you capture a couple of face images from your friends. So with these images, we build reference visual identity models, okay? And then, of course, it's better if you can capture them from different angles and so on, but not very critical. And then what you do while playing the game is that you monitor your environment through your mobile phone's camera. If you see your opponent, you click the shoot button. It detects the face. It recognizes the face. Then you know who has shot whom. So maybe you might remember it was, I think, called Pokemon Go, where you were interacting with some digital assets. This game was before that. This is also a very old application, by the way. It was to provide more a human-human interaction. We like this game very much, and that's why I still show the video, I think after 10 years, because this video, this application or this game also reflects one of our visions. Like at the very beginning, I told you that for us, human-human interaction is the main thing. We want computers to be the butlers. We want them to work in the background. We don't want them to get our attention all the time. But we also accept that it is almost impossible these days to like separate people from their mobile phones. So instead, what we do is then build games that let people keep their mobile phones, but use it for also human-human interaction. I think this game reflects our idea very well. Another type of face recognition work we have done was on mismatched face recognition, or sometimes it's also named cross-resolution face recognition, where you have high-resolution, high-quality reference images of people, and then you need to monitor them in outdoor, low-quality, low-resolution surveillance cameras, and you need to match these two sets. So it's a very difficult problem. I think at that time we ranked first in the challenge in 2016, but our accuracy was around 70%. Nowadays we can achieve over 95% correct classification rate with this problem. So this is more recent work. This is in collaboration with EPFL and then University of Ljubljana. So we worked a lot on face super resolution, but when you work on realistic face super resolution, I mean, or real world super resolution, we notice that it doesn't work very well. What I mean is that instead of like downsampling an image with a factor, if you get a genuinely low resolution face, and if you perform super resolution, then we notice that it's almost useless. Because super resolution is really a difficult problem, especially if the upscaling factor that you need is very high. So then the idea we had first was, if we cannot realistically upsample the data, then why don't we downsample the reference data, high quality reference data? Like you have this high resolution reference gallery image, and this is how these are the cameras that you monitor the people. So instead of trying to upsample them, square resolve them, the approach we had was to realistically downsample this image so that you kind of try to fill the domain gap. So instead of trying to move this to this domain, trying to move a high resolution gallery image to a low resolution domain is easier actually. And we have seen that it is very useful. This was the work we have done with EPFL. And then with the University of Ljubljana, their expertise was upsampling, super resolution, and we already had some expertise on downsampling. The idea was to combine them. For example, you need an upsample factor of 10. But what we say, instead of doing it, if you can do it 2 very well, like if you can upsample by a factor of 2, just do it. And then we will come to your resolution. So we don't then downsample that much, but we would also downsample a bit less. And then we will meet in the middle. That was the idea. And it also worked very well. The main outcome for this study was if the resolution is not too bad. What I mean too bad is that there are some data sets that capture people from drones. And this type of data, it's really very noisy. And we didn't see an advantage of like upsampling at all. So for those type of data, only downsampling was fine. But if it's not that bad, then this combined approach helps better. We also did a lot of work on occlusion robust face recognition, especially during the COVID time with the use of masks, especially if you use the masks till your eye level, or if you use sunglasses, it's still a challenge for the recognition systems. We have done some work on cross-domain matching, like if you have thermal reference images, and then if you are monitoring people in visible domain or the vice versa, if you have some visible reference images of people, and if you are monitoring the space with thermal cameras, we were trying to match them. For face spoofing, we developed a patch-based system, and then actually shuffled version of it worked better. So the main objective here was to use patches to increase the amount of data and also like have some location information, and this way try to improve the generalization of these systems. Although we work a lot on face recognition, we are also working on the identification. This was one of our first works. I think it was one of the first uses of guns, I think the first one, for face identification purposes. And recently, IZZET is working on using LLMs plus some other technologies for attribute preserving face anonymization. So we are still working on it. This is also a part of our European Union project. Another thing you can do is perform facial expression analysis. So there are different tasks within facial expression analysis. You can perform discrete, not a very correct word, but emotion classification, like classifying these 7 universal emotions. Like in this video, you can do action unit detection, like the muscle movements, and also action unit intensity estimation, how much they move. You can also do arousal valence analysis and so on. For us, we have mainly worked on either discrete emotion classification or action unit detection and intensity estimation. We also built a gamification game based on this. And actually, we also had a spin-off company out of this idea, but was not successful in the end. So this was an application that we developed when we were offering a course named Autism and Computational Approaches. So kids with autism, they cannot have eye contact, therefore they do not perceive, I mean, they are not used to perceive faces, so they don't have much experience. So this was a kind of game to let people practice their facial expression, like expressive face skills, let's say. So we show an expressive face, and then we ask you to imitate that. And then the question is how well you have done the imitation. So we know the reference action units. We can analyze your face and check which action units you have moved to just a simple intersection of or over union, and then provide an imitation rate. The nice thing we observed here is that the more you play this game, the better you get with the imitation. This is something that you can practice, which is, I think, known, especially in sales. I heard that like you need to smile properly and so on, and then it seems that there are some classes for that. The other thing is that although the purpose here was like helping kids with autism, everybody liked it very much. And then the idea of that company was building an imitation game, kind of what we named at that time was a social network. So it was a social network where you like send expressive faces to your, I mean, mainly you challenge, you do a funny face or you find a funny face from internet and send it to your friend, and then you challenge your friend. So we were trying to build a face-to-face communication between people. So again, we don't like mobile phones, although we are addicted to the mobile phones. So we think a lot about how to use mobile phones so that people can also physically interact. We don't like social media either. That's why we were thinking about like how to enable social media to have more face-to-face interaction. So this was one of the ideas. But of course, at that time, the problem becomes a bit different because you receive an image without a label. You don't have the annotations. And then you need to imitate it. So you also capture your own face. So then the idea is it's a kind of pair matching in face recognition. So you have two expressive faces, and independent on the identity, ethnicity, age, gender, and so on, you need to decide how much these two expressions match. So then that was the problem at that time. We have also done some work on face animation and expression transfer in real time. Although, of course, now with the current technology, we are doing these type of things in a different manner. At that time, what we have done was using the topology of the face, although our eyes, I mean, we have different eyes, nose, and mouth, and so on. They are located similarly, so you can calculate a statistical distribution about possible positions or anti relations between them, and then you can use this for like visual puppeting purposes. We have also done a lot of work on COVID time requirements, let's say like face mask detection or proper mask wearing detection. We built a nice data set on face-hand interaction detection. I think this is also very important even without the COVID. We tend to put our hands a lot on our faces. This is something I also do very often, like you do this or this very often, and this is not very healthy. And I think this is a main requirement. Maybe we can build a plugin for that to prevent people to put their hands on their faces. And we have also done some work on social distance monitoring. We are also very much interested in gait identification. This is a field that amazes me. I mean, this, how do you say, our talent that enables us to recognize people from the way they walk. It really amazes me. But the computer prized recognition of people from the way they walk. It's not at that stage. So I feel like this is a very interesting and still an open problem. We have done some work on fight detection from social media. This was in collaboration with Qatar Computing Research Institute. So the main idea was to detect some fight images, especially from social media or in public spaces. I think at that time there were some problems at metro stations and so on. So we were thinking whether we can detect them in real time, these fight situations. We have done a very nice work on anomaly detection. This was a joint work with ISTI-CNR in Pisa. So it was a nice Turkish-Italian collaboration, and we named it as MOCA. So the idea here is, as the title says, anomaly detection, and the way we formulate it was we designed one class classifier. So we were trying to model what normal is, and if it's outside of this, then we classify it as anomaly. So this was the formulation in this work. And then we built a general framework. So actually we had two frameworks, one for single images and one for videos. And this is a general purpose anomaly detection. So it can be an imperfect part in a production line, or it can be a cyclist violating a no cycling zone. So this was a generic framework for anomaly detection. We have done some work on foot recognition. This was with Hamad bin Khalifa University in Qatar. The foot here is good, but it's also very fatty, and it's also very sweet. And it seems that diabetics is a big problem here. So at that time, we built a mobile application. I did a similar project, I think, over 15 years ago when I was in Germany. We had a collaboration with Intel Research at that time. And then at that time, we were checking the people's calorie intake in fast food restaurants. We are also interested in like search and rescue type of work after disasters, especially through the images acquired from a drone network or from social media. So we built a video data set, instant data sets that we named as VIDI. And then we are still working within that TÜBİTAK project on assessing the damage after the earthquakes, trying to find the crafts and also the open roads. We have done some work on crowd density estimation, again for using drones, some lightweight models for fire detection, and then a little work on UAV detection. Okay, maybe I can speed up a bit. So our first works on document classification was about categorization. So we were trying to categorize the documents. At that time, we were working with an archive company. So for example, you get a folder for tuple, and it has many different documents like the photocopies of identity cards, I don't know, maybe your loan documents and so on. So at that time, they asked us to automatically categorize all these documents. And then we have noticed that even without checking the contents, just from the appearance, using neural networks, you can classify them successfully. And the next work was about this. It was a collaboration with IBM Zurich and EPFL. So it was about form understanding in noise scanned documents. At that time, we had a collaboration from hospitals, so we were trying to understand some medical documents. And then we noticed that there is a data set need in this field, and obviously we cannot release these medical records. So what we did instead was using a publicly available data set. I think at that time it was the tobacco. We provide the annotations and then built this data set. We have done some work on also signature verification. So you have some reference signatures and then you have a target signature and you need to match them. In Turkey, the problem is that they like to put stamps on everything. So then the problem here was how to clean these backgrounds. So at that time, we benefited from cycle guns to remove the stamp. And then after removing the stamp, we were matching the signatures. This is the work we have conducted with TechPen Engineering. So you get these piping and instrumentation documents. So what you need to do is that to detect these components, detect the text, and combine them for understanding purposes. So especially the understanding part was quite challenging. We have done some work on text detection. So this is a more recent line of work that Ziya is leading. By the way, Ziya is also from Ankara. I think he also studied in METÜ for a while. We do some work on brain tumor segmentation, pedicle segmentation. We have some other ongoing works. I think with Medeniyet University, we will start work on chest cancer. And then with Istanbul University, Çapa Medicine Faculty, we will start another, they call retrospective work on a specific type of cancer. So we are getting very active in medical field, thanks to Ziya. As I informed you already, together with a startup company, we worked a lot on the eyes. Eyes are not only, how do they call, windows of our soul, but they also really reveal a lot of health-related information. That's what we tried to do. We had some promising results, but not as high as we would have liked it to be, not as high as that it can become commercialized, but it opened us a whole new world. This is also a very interesting research field. And another work we have done, this was in collaboration with CNR, again with Italy, another research group there. We were trying to estimate human pose, like laying pose estimation. And of course, you need to be also a bit privacy preserving in this type of applications. Then they use different types of sensors also, or you can approach the problem in a multimodal way. While I was with EPFL, we have done several work. We worked a lot on spare resolution. They are not here, I think. This cleanest index work was also very interesting. I think it also received a lot of attention in the literature. So at that time, it was also together with a startup company. We put a camera on the street sweepers. And this way, we were trying to capture the images of the streets and then also detect the littering or the objects. And then this way, get a distribution or get an idea of how clean the city. This way you can also like schedule these sweepers accordingly, or if you see a part of the town is more dirty, maybe you can also put higher taxes on them. So we have done a lot of work on lip reading. These works also had a nice impact. So at that time, we were using a hybrid system, both neural network and more traditional way of performing it. We have done some LiDAR plus RGB pedestrian detection, and then we had the work on melanoma segmentation. Recently, we work more with KIT again. So we were collaborating on a German project named Organic Machine Learning. And then after that, we have started now the European project with them. So for a while, we worked a lot on like alpha meta generation and related problems because Zoom Research Europe is located in Karlsruhe, and actually it is a former spin-off of our lab. That's why we are very close with them. And then we also get some research ideas, or we get some wishes from them. So one of them is alpha meta generation. This, you can think this as a kind of a soft segmentation instead of like background and foreground. It's a bit more, let's say, soft. And the idea here is that if you are using a background during a video conferencing system, to make it look more realistic. While doing this, we have noticed that during a video conferencing, if you are sitting next to the window, or if you forget to switch on the lights and so on, you might get an underexposure or overexposure situation. And the illumination levels, then in these situations, they cause a big problem. And alpha meta generation, the performance of alpha meta generation gets affected a lot. So what we have done then is using a single model, both for overexposure and underexposure, we tried to adjust the illumination level in the image. And this is a bit more recent work. We have one more work coming in CVPR at Antiere workshop this year. So this is the face dubbing work I mentioned. So it's video to video speech translation. You have an input video with the original language. And then the output video is a kind of manipulated video according to the target language.
You do, but your performance in American Hustle, everything you do, but your performance in American Hustle.
Alles, was sie tun, außer ihre Leistung in einem Asse.
But it was also fun to, I remember one day I was sitting in the makeup trailer and I was having a conversation with
Käfer, aber es war auch lustig, sich an einen Tag zu erinnern, als ich im Akkordeonwagen saß und ich ein Gespräch mit.
Obviously, this is a huge system because you need to do speech recognition, machine translation, then speech synthesis and generate the speech. And meanwhile, our part was more on the visual part. And for us, one of the main challenges is lip synchronization. So we are still working on this problem.
Everything you do.
So this was a kind of quick summary about what we have done and what we are currently doing. I thank my students. They do all the work, and I have the privilege to present their work to you. So thank you for your attention.